Hello, everyone, and welcome to CogNosco Ascolto, the official scientific podcast of CogNosco Lab. This podcast series highlights our research in cognitive science and artificial intelligence.
Welcome back, everybody, to the deep dive. Have you ever wondered if you can actually train your brain to be more creative?
That's a question a lot of people have, yeah.
Well, today we're going to be diving into some brand new research that suggests the answer might be yes.
That's right. We're looking at a study straight from the Psychology of Aesthetics, Creativity, and the Arts Journal.
Oh, wow.
It was just published last month.
Hot off the press. So, what is the big idea here? Can you break it down for me and our listeners?
Well, scientists, they're always looking for ways to measure and understand creativity.
Yeah.
Especially in science. And this study introduces a fascinating new tool called the word sentence construction task, or as they call it for short, Woseco.
Woseco. Okay, that sounds...
I have to be on the fall.
Yeah, it does sound a little intimidating.
It's not that bad once you get the hang of it.
Uh-huh.
The Woseco task is all about capturing how people connect scientific concepts. Think of it like that game.
Yeah.
That game where you have to connect two totally random words like elephant and toaster, whatever.
With a story.
Yeah, by creating a story, exactly.
Okay.
But in this case, we're not talking about elephants and toasters.
Right.
We're talking about, like gravity and photosynthesis.
I see. Okay.
So more on the sciencey side.
Got it.
Yeah.
Okay, so I'm starting to get it, but why is this new task so important?
Well, it's important because it lets researchers actually visualize someone's semantic network.
Hold on. Semantic network. Maybe we need to give the listener a little reminder about what that is.
You're right, yeah.
Yeah.
Think of a semantic network, like a map, like a mental map
of
all the knowledge in your brain.
I like that.
Every concept, photosynthesis or gravity,
Yeah.
those are like points on the map. And the connections between those points represent how your brain links those ideas together.
So somebody with a really well-developed semantic network would have all sorts of roads and pathways between all those different concepts.
That's a great way to put it, exactly. And what's cool about this is the Woseco task allows researchers to see those connections being made in real time. Gives them a window into how people are thinking creatively.
That's blowing my mind a little bit. So did the researchers actually find that the Woseco task is better than other methods for measuring creativity?
Yeah, they did. The study actually tested Woseco with high school students in Austria.
Wow.
Using scientific concepts.
Oh.
And the results were really fascinating.
Oh, cool.
What they found is that the Woseco task revealed much more complex and interconnected semantic networks than, say, a traditional word fluency task, where they just ask people to list
off words.
as many related words as they can.
Oh, okay. So it's really...
So it's like Woseco's giving us a much higher definition picture of their understanding.
Yeah.
It's like the difference between a blurry snapshot and a high definition picture.
Yeah, like that.
Yeah. And that basically means the Woseco task might be a more sensitive tool to find those hidden patterns of scientific creativity.
So we know that Woseco's good at revealing these semantic networks, but what are the researchers looking for in those networks? What makes one network more creative than another?
That's a great question. So they're looking for certain characteristics that suggest a brain is wired for creative thinking, right? One of those characteristics is something called average shortest path length.
Okay, I'm intrigued, but I'm going to need you to break that one down for me and the listener.
Yeah, so imagine you're trying to get from the concept of gravity to the concept of photosynthesis in your brain.
Okay, yeah.
If your brain has a well-developed semantic network, it's kind of like having a superhighway between those two topics. You can get from one to the other really quickly and easily and make those connections. That's what a shorter path length means.
So fewer mental traffic jams for creative thinkers.
Fewer mental traffic jams.
Okay,
like that. Another key characteristic is something called the clustering coefficient.
Okay.
Now, imagine your mental library has, specialized neighborhoods for different subjects, right?
Yeah, like a physics corner.
Yeah, exactly.
And a biology block.
Exactly. So like a physics corner, a biology block.
Chemistry lab over there?
Chemistry lab, yeah. a higher clustering coefficient.
Okay.
Means those neighborhoods are really well defined.
Yeah?
Lots of interconnected concepts all clustered together.
Okay.
But here's where it gets a little more interesting.
Okay.
The third characteristic, modularity, is actually about how flexible those boundaries are.
So less organized is better?
Kind of.
Yeah.
A brain with lower modularity is less rigidly divided, right? Okay. Into these separate compartments, meaning you can more easily make connections across those different neighborhoods.
So a less organized brain is actually better for creativity. Okay, that's kind of counterintuitive. Tell me a little more about how that works.
So think of it this way. If your mental library is too compartmentalized, it might be hard to see how, an idea from physics could apply to a problem in biology.
Oh, okay.
But if the boundaries are a little bit more fluid, you can, freely roam between those different domains.
Yeah.
And that's what lets you make those unexpected connections that can lead to breakthroughs.
This is making me rethink my whole approach to organization.
Yeah, maybe a little bit.
So are people just born with these creative semantic networks, or can we actually change them and develop them?
That's the million-dollar question. And that's where the next part of the study comes in.
Oh, okay. All right.
They had some of those high school students participate in a special creativity training program.
Ooh.
Before taking the Woseco task.
A creativity training program for teenagers. Okay, I have to hear more about this.
Yeah, so this program, it's called the Scientific Creativity in Practice Program.
Okay.
Or SCIP for short.
Got it.
And it focuses on things like problem solving, divergent thinking, and integrating scientific concepts in new ways.
Sounds like a pretty intense brain boot camp.
It kind of is, yeah.
Yeah.
So the big question is, did they see any changes in the students' semantic networks after this training?
Yeah.
And that's what we're going to dive into next.
Oh, man.
The results of this program are really exciting, and they have huge implications for how we think about creativity.
Okay, I can't wait. We'll be back in a flash to unpack those results right here on the deep dive.
All right, so we're back. And before the break, we were talking about whether or not you can actually train your brain to be more creative.
Right. Those teenagers in the study.
Yeah. Who went through the SCIP program.
Right. The Scientific Creativity and Practice Program.
Yeah, that's the one.
That sounds so cool.
And it was pretty intense. A lot of...
Like a brain boot camp?
Yeah.
Yeah, basically, yeah.
Yeah. So did it work?
It did. They saw some pretty big changes in the students' semantic networks after the training.
Oh, wow.
Yeah. So they became more interconnected, more flexible, and overall, they started to look more like the semantic networks of those highly creative individuals.
So it's not just about being born with a creative brain.
Right.
You can actually train your brain to be more creative.
It seems that way, yeah.
That's amazing. This has to have huge implications for education, right?
Absolutely. I mean, it really challenges this whole idea that creativity is some kind of fixed trait.
Right.
Like you're either born with it or you're not.
Yeah.
But this suggests that maybe it's more like a muscle you can exercise and develop.
So what if we integrated this kind of training into schools?
Right.
Like from a young age.
From a young age, imagine that.
Yeah.
Instead of just, drilling facts and formulas, you could actually be training kids to be innovators and problem solvers.
I love that.
Yeah.
So this research focused on scientific creativity.
It did, yeah.
Is there something unique about that?
That's a great question.
Like about the way scientists approach creative thinking?
Scientific creativity is interesting because it requires this really special blend of imagination and rigorous testing.
Right.
So it's about pushing the boundaries of what we know, but also staying grounded in, evidence and reason.
So you can't just come up with these wild ideas.
Right. You got to be able to test them.
You have to.
Refine them. Yeah. See if they actually hold up.
Contribute something meaningful to our understanding of the world.
Yeah, exactly. And the Woseco task, with its emphasis on making those meaningful connections between scientific concepts.
I think that's what really taps into that unique form of creativity.
Okay. So this makes me wonder about all the different flavors of creativity.
Yeah.
Do you think a musician's brain is wired differently than, say, a painter's brain or a writer's brain?
That's a great question. And honestly, we're still figuring that out.
Okay.
But it is possible that, different creative domains might rely on different patterns of connectivity in the brain.
So maybe a composer's semantic network is all about the relationships between sounds and emotions.
It could be.
And then like a visual artist is all about the interplay of color and shapes and form.
Yeah, exactly.
Oh, man.
So each creative field could have its own kind of unique neural fingerprint.
That's really cool.
Yeah. It's exciting to think about the possibilities if we could actually start to like map out these creative networks and see how they differ.
Yeah. So let's bring it back to our listeners here.
Okay.
What does all of this research really mean for somebody
who wants to like boost their own creativity?
Well, I think one of the big takeaways is that we can all cultivate our own creativity, right? It's not about waiting for a lightning bolt of inspiration to strike.
Yeah.
It's about understanding how our brains work and taking those deliberate steps.
Okay, so what are some of those deliberate steps we can take?
One of the most powerful things, and this came up again and again in the research, is to make connections between seemingly unrelated fields.
So I should put down the physics textbook and pick up a novel?
Maybe, or sign up for a pottery class,
Yeah, or a pottery class. Expose yourself to new ideas.
Yeah.
New perspectives, new ways of thinking.
I like that.
Read outside your usual interests.
Yeah.
Attend talks on topics you know nothing about.
Yeah.
Strike up conversations with people from different backgrounds.
Like shake up that snow globe of your mind and see what new patterns emerge.
Yeah. But sometimes those connections can feel a little random.
Right. How do you know which ones to pursue?
That's where that balance of divergent and convergent thinking comes in.
Okay.
It's great to be open to those unexpected connections.
Yeah.
But you also have to be able to step back, critically evaluate your ideas.
Right, yeah.
And figure out which ones really have potential.
So it's not enough to just be like a fountain of ideas.
No.
You have to actually be able to like...
You got to shape and mold those ideas into something tangible.
I like that.
Yeah.
So we've covered a lot of ground today.
We have.
We talked about semantic networks, creativity training, the unique characteristics of scientific thinking. But what about those other types of creativity, like artistic or musical?
Right.
That's where we're headed next.
It is.
We'll explore how those creative sparks fly in different fields and what we can all learn from those breakthroughs.
Looking forward to it.
So stay tuned, folks. We're about to uncover even more secrets of the creative mind right here on The Deep Dive. Welcome back to The Deep Dive. We've been talking about scientific creativity, and I have to say, this has been really eye-opening for me.
Me too.
I mean, thinking about creativity as a skill that we can actually develop.
It's empowering, isn't it?
It is. It's not some mystical gift, you know?
Exactly.
So one of the things that has really stuck with me is the importance of making those connections between different fields.
Yeah, like those examples we talked about earlier.
Exactly, like using the Ising model from physics to understand, like, personality and psychology.
Yeah, who would have thought?
That blew my mind.
Or even the invention of Velcro.
Oh, yeah?
Being inspired by those little burrs you find out in nature.
Right.
It's like somebody took the time to actually, like, look at those little burrs and think about how they worked.
It makes you wonder what other connections are still out there. So what can our listeners do?
Well, if you want to boost your own creativity, think about those connections, right?
Okay.
Challenge yourself to read outside your usual interests.
Okay. Yeah.
Go to a lecture on a topic you know nothing about.
That's a good idea.
Talk to people from different backgrounds, different fields.
Like, shake things up a little bit.
Yeah. You got to cross-pollinate those ideas.
I love that. But sometimes those connections can feel random.
Yeah, that's true.
How do you know which ones to pursue?
So that's where that balance comes in.
Okay.
You know, that balance of divergent and convergent thinking.
Right.
You need to be able to come up with those crazy ideas, but also be able to step back and critically evaluate them. Figure out which ones actually have potential.
So you can't just be like a brainstorming machine.
No, you got to be a sculptor too.
You have to, shape them.
You got to shape and mold those ideas into something real.
So it's not enough to just have the ideas.
Okay.
You have to put in the work.
It's like that old saying, 1% inspiration, 99% perspiration.
Yeah, do the work.
You got to do the work.
Yeah.
So the beauty of it is, this is something anyone can do.
I love that.
Creativity is a process, it's not.
It is a process, yeah.
It's a destination.
This has been such an inspiring deep dive.
It really has.
I hope our listeners feel, like, fired up.
Yeah, me too.
About their own creative potential.
So remember, you have the power to unlock your creativity.
You do.
It's all about embracing the unexpected.
Making those connections.
Making those connections, exactly.
Never stop exploring.
Yeah, keep driving deep.
Well, on that note, we're going to wrap up this deep dive.
It's been a pleasure.
I had a great time.
Me too.
Until next time, fellow knowledge seekers, this is The Deep Dive signing off.